Okay, this was the more density math practice. Real quick, I apologize for my voice. I don't have much one right now. I just want to define density. The density is the amount of stuff. So it's the number of grams in 1 unit of space. Okay? So when it asks for a density, we already know this unit. We're not sure of this one. So the block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams. So we can change that up a little bit. We can make that a for every statement. So we can say for every 40.5 grams of aluminum, there is 15 milliliters of space. And then it asks for the density. So we just want to know for every blank grams of aluminum, there is 1 milliliter of space. Okay, so to get here to here, divide by 15. Get from here to here then, we'd also divide by 15. And if we think about this, 45 divided by 15 would be 3. And so it's a little bit less than 3. And I would pull out a calculator then and figure that out. And it would be 2.7. And if we look at the number 6 figs, this needs to be 2.70. Okay. What volume of silver metal will weigh exactly 2,500 grams? And they tell us that the density of silver is 10.5 grams per centimeter cubed. So that density tells us for every 10.5 grams of silver, there is 1 centimeter cubed of space. Right? That's what that density tells us right here. And we don't want to know 10.5 grams. We want to know 2,500 grams of silver. There is blank centimeters cubed of space. Okay, so to get from here to here, well, it's getting a lot bigger. So we can take 2,500, divide that by 10.5, and that comes out to be 238. So this is 238 times greater. 238 here. And that is the proper number of significant figures. Okay. All right. If you can do 1 and 2, I'm pretty confident that that's pretty much all we're going to ask you to do on a quiz. These are more challenging problems that might, come up as like one question on a quiz or a quick one, just to test to see if you can do something like this. In the United States, copper pennies, made since 1983, actually contain very little copper. If a penny contains 93, let me just underline that, 0.975% of its total volume zinc, and then the other percent is actually copper, what is the apparent density? So they want to know, here are the two densities of those two metals. Now we got a little bit of work we got to do in order to figure out all the rest. All right? So we could say for every 8.94 grams of copper, there is 1 centimeter cubed. And then for every 7.14 grams of zinc, there is 1 centimeter cubed. Okay, so this tells us that basically this is the percentage. So this is 0.93975 centimeters cubed of space is zinc. And down here, 0.06025 centimeters cubed of space is copper, back up here. So if I multiply those two out, this will be times 0.93975 times 0.93975. That is 6.7 136 grams of zinc. And then the rest of it's going to be copper. So this will be times 0.06025 times 0.06025. And that is 0.539 grams. And if you think about it this way, like when we add these two values up, they are 1 centimeter cubed. So if I wanted to know how much those two as 1 centimeter cubed weighed, I just add these two up. So that's 6.71 plus 0.539 is equal to 7.25 is the correct answer. Write that up here. 7.25 grams per centimeter cubed. Again, the reason that works is because these two numbers add up to that 1, right? And then these two numbers must add up to the amount that the mass is. Okay. Number 4. Object A is less dense than object B. If both objects have the same mass, what can be said about the volume of object A compared to the volume of B? All right, so if they have the same mass, that means they take up the same amount of space. So if we, or the same amount of, there's the same number of particles. So let's make object A be one circle is equal to 1 gram of A, right? And then let's make object B, we got an A. Object B, one triangle is equal to 1 gram of B. So let's just say, for instance, we've got 3 circles of A, and that means we've got 3 triangles because they said they have the same mass. But it said that object A is less dense. That must mean that there's more spacing, when the only way that there's more spacing is if the container is bigger. So object A has a larger volume than object B. Now there's mathematical ways to figure that out too, but drawing a picture certainly can help you think about